Okay, hello and welcome to my talk, which will be about Qubes Air and kind of my opinionated view on some proposition for security-conscious technical professionals. So that's me. I'm founder of 3MDEP. 3MDEP is essentially an organization which kind of trying to transition from the service-based to product-based. So there are three kind of, you see that there are chess here. I'm a chess player, love chess. And so there are three kind of levels here. So this is probably the most common. This is Dasharo, which is kind of our most successful brand. This is pace enterprise training, essentially the pawn, which is enlightened because of the knowledge it gets. At some point, maybe it will be king, who knows. So which is like our educational proposition and kind of productized education. And Zarhus is embedded Linux, trying to be a place where we exercise root of trust, chain of trust technology, and close to hardware provisioning of those technology to build more trustworthy solutions. Okay, so yeah, I wanted to start with some problem statement, which I call frictions here. And maybe let's set the stage with some actors. So for my story, we have three actors. We have experts, adversaries, and auditors. So experts are essentially experienced professionals. Could be, I don't know, maybe quality assurance of mission critical software. Could be someone who's dealing with confidential and top secret documents, maybe researchers. I guess recently very huge and important group is the group which trying to do self-hosted GPUs for LLM inference. And the point essentially here is that those experts have to deal with some highly confidential stuff, some keys maybe have some serious needs for. So adversaries could be internal, external. Auditors, very common stuff today. We even have some talk about CRA tomorrow. So those are essentially people responsible for providing compliance, maybe certification. Yeah. Why them? So those players typically have need for resources, and essentially they have resources to afford certain solutions, which may be not that cheap. And they can pay the price if it really improves their quality of life. So they can have longer sleep, for example, because of problems which are taken care of, CVEs, maybe less afraid of recent malware, recent ransomware, or whatever, either working or not working, depending on the site you are on. Maybe there are some which are in supply chain, software supply chain, and really have to care about infection. So software producibility is very important for them. They also may have may care a lot about trust boundaries and essentially maintenance of all whole stack. So this talk was influenced by some smaller project that we did, which was essentially documentation, which part of the document, so it was clarification of the verified boot process. We will do follow-ups on that, comparing x86 Android and iPhone boot process. But the previous project, which was sponsored by PowerUp Privacy, was creating a threat model persona and threat model, which was very tiny, small stuff. There was very simple documents. By the way, slides are on the cfp3mdep.com, so you can go there and look at it. We essentially did that for PowerUp Privacy, and doing that, I realized, okay, if I will connect all these pieces, I will probably have Qubes Air with some user-controlled root of trust and chain of trust technology. And that's what I want to talk here. So, of course, key management is a world-class issue, and I will not claim we'll solve anything of that. But everyone got this issue, like multiple keys, okay, should it go to HSM, what kind of tree I have here, I have this multiple releases, maybe for this product, for that product, and this is confusing at some point, is complex. Also, maintaining root of trust and chain of trust means more keys. So most of recent security issues are coming from key mismanagement. If you heard about Intel bootguard issues recently in various mass media or UEFI secure boot problems, those are not because of the design of those features. Those are because of mismanagement of the keys. Someone leaked something, someone, I don't know, used test keys, for example, for secure boot, and that was the issue. So that's one problem. So what we have today, we essentially have USB sticks, we have HSMs, maybe if we have enough money. Many orgs got this spread across employees, maybe on various laptops. Many organizations claiming that, okay, we have this developer workstation, that's the builds and that's the signing, and that's how we do the release, yeah? And of course, that's kind of a risk. Yeah, as I said, we will not solve all these issues, but I think Qubes Air architecture may have improved or may have some proposition to improve that. Another friction that we have is essentially reproducibility of the builds, especially if we are very paranoid about that, not about only reproducibility of the builds, but also about signing, doing that by multiple parties, signing those, publishing those to some log, in which we can then mutually agree that this is the valid hash of this software. There is something in Qubes Air that can help with that. I also huge proponent in 3MDev, for example, do not build core boot, Yocto, or whatever huge system on your machine, because you're essentially killing the disk. And essentially, I'm coming and I asking, what are you doing? And compiling, yeah, like XKCD comic where they just compiling, yeah. And of course, that wastes money of the organization. My laptop is unusable because I'm compiling. Yeah, so yeah, but that's not the only problem with local builds. Of course, with local builds, we have a problem with the customization of the tool chains, customization of the special scripts, base images. Of course, we're trying to solve that with containers, but then distribution of the containers, versioning of the containers, question about the reproducibility of those containers, another set of issues. Others do the virtual machines, just saving virtual machines, and then they trying to use that. So there is also a story that someone keeping in the basement very old machine, like a mainframe, because there is some software 50 years after just running, and from time to time we have to fix it. So that's also not a solution, yeah? Also, Qubes Air, I don't think it will solve all these problems, but may have in addressing some of those because of the ability to delegate in secure manner and policy controlled way the job to the server, to more dedicated ecosystem. Okay, and then, of course, this is very opinionated and calculate only in my world, maybe not in your. But if we connect keys and we connect building, then we have something that, like Dasharo release or some software release, some Zarhus release, which we have to deploy. And of course, we would like to do that in the environment where there is user-controlled root of trust provisioned and the chain of trust. So that means there are some tooling around that to glue the image together, glue the BIOS together, glue the operating system together. And to do that correctly, you probably need some silicon vendor key generation, maybe some stitching, maybe some signing tools. Maybe there is some OEM tool to that. And this can be quickly very, very confusing. There is a solution for that because hyperscalers already recognize this problem. So Google, AMD, many others invest in Calyptra. Why they do this? Because they claim the silicon vendors do not provide coherent, consistent environment for provisioning root of trust and configuring chain of trust. And they're solving that with big money. And I don't know if we ever get that, but essentially this is huge thing already addressed by the big players. And of course, they most likely commoditize, they complement, not only solve the problem, but solve the problem mostly for themselves. It would be probably very hard to use OpenTitan or Calyptra by our own. So we have to somehow deal with this. Okay, I guess I mostly told you about that. So this is related with UEFI secure boot. It is related with Intel boot guard. So essentially establishing stable root of trust on the machine. And delivering that for some organization which can leverage those keys for building correct images, deploy that in the infrastructure. There are two more cases which I have to mention, because if I will not mention it, it will be not noticed by the investors and anyone who's got money. So I have to talk about this situation when we have GPU server just processing some data, likely some very private one, and we have data leaks. So of course, like using some compartmentalization here could help in that if we have stateless GPUs. And of course, like there are more issues with that, but anyway, let's say Qubes Air can help us go in that direction. And the other thing is, of course, we have CRA, we have other NIS2 and more compliance because if LLMs will generate more random code, we will have more vulnerabilities. Then those guys will come to us and will say, how you generated that code? Please give me audit log for that. What hardware? What root of trust? What software? And then, of course, we will have to deliver that. And if our infrastructure is in this shape, then, of course, we will get garbage. So Qubes Air, essentially, right now, is because of the problem with key management, problem with building on our tiny machines, and need for better compute, then maybe isolation of some workloads, then maybe compliance. Because maybe it would be easier with Qubes Air OS to get the log, what happened when, and who did that. OK, so this is Joanna initial publication in 2018. So Joanna writing is essentially one of the most influential in FOSS crowd in the space of privacy and security. We know x86 considered harmful, stateless laptop. Maybe Qubes Air is not so well known. It was published in January 2018, and with the aim of generalizing Qubes OS architecture. So to make things clear, there are some things which are out of scope from my side. First thing is old hardware. I don't care about old hardware. Old hardware is very nice for museum. Of course, if someone can do stuff, museal high-value stuff, then yes, congratulations, use that. But it's very hard for keeping up the business going with museal artifacts. Yeah, so that's something that is out of scope for me right now. Other thing which I think Joanna took into consideration, and from my opinion, it's not something that I will consider. So Qubes Air in public cloud, or maybe it could be in some confidential computing, well-attested cloud. That's maybe fine for some limited use cases, but we will have to define that. And the third thing which I not consider is that either this site or this site is not owned by me, or not owned by my organization. So where I'm buying hardware from third party, and root of trust and chain of trust is owned by someone else. So this is also something that, in my consideration, is not good thing, and I don't plan to invest into that. OK, so according to Joanna, what were the initial reasons for Qubes Air? First of all, is that deployment costs. That essentially, at the point when she published, this was the same what Alyssa said about my laptop does not get correct Qubes installation, yeah, or good Qubes installation. There are some problems in installing. There have to be someone who's supporting me in installation. And at the point when Joanna published that, of course, there were problems to find hardware that Qubes OS installed. From that point, we moved it on. We have Qubes OS certified laptops. We probably can deploy on like many devices which are reported in HCL. So that problem is little bit controlled and little bit, maybe, I'm not saying outdated, but at least controlled. But then we still have devices, and we have need for better compute, for hardcore compute, yeah, which those devices cannot handle. So there is still valid case for valid deployment case for Qubes Air as a delegation of the compute or dedicated compute to some other machine. And second consideration by Joanna was blaming the hypervisors and blaming the x86 architectures. She was more correct than we think. Now we know she was more correct than probably she know back then, because back then she know about Spectre and Meltdown, but didn't know yet about everything that came after. So yes, x86 is considered harmful, a lot of problems there, and Qubes Air was the way to avoid it. I think Zen is still valid good foundation for the Qubes Air, especially going the compliance, going into automotive. Thanks to that, it would be better and better. And maybe if we remove DOM 0, then it will be really great. And there are also other alternative supports which kind of try to solve the issue of this Spectre Meltdown and architectural problems, like memory tagging, control flow integrity, cherry, this kind of stuff. So to summarize the approach that Joanna proposed in this article, I think Qubes Air is about minimizing and controlling interface between components, and more isolated components with well-defined interfaces are better than unified bloated system. Yeah, so there are some still, if someone is long enough with Qubes OS, know that there are some dreams here, which are still after 7 years, like this one, GUI VM, like this one, I guess, to some extent, but you can already solve that in some way. But there is one dream which is already resolved recently, which is this one, like the remote qrexec, which coming in 4.3, and that's what I'm very excited about. And that's what I want to talk about. There are more things in this article, more vision and greater vision from Joanna that I will not dive in. There is one small thing that I want to mention. There are Qubes zones. So essentially, Qubes zones is another concept built on top of Qubes Air, which could bring a very interesting topic of distributed reproducibility as a proof of correctness. As well as those multiple signed reproduction proofs in situation when someone is really extremely paranoid about the supply chain attacks. So you can already see that there are multiple zones. There is some admin, which can essentially, for example, here is Raspberry Pi. This can be some server. This can be some other devices. This could be ARM. This could be x86. And maybe even this small could be RISC-V. And then you compute on different stacks. And if you get the same results, that means there is some consensus. And that really means that it's very hard to compromise that in those three environments in parallel. OK, that slide is extremely packed. So, but I tried to give motivation for Qubes Air in 2025. And that motivation coming from the ecosystem, from various people that I'm working with, that visited Dasharo user group, video conference. So that one is from really, really positively crazy people from Distrust, from Silicon Valley. They have this tool, this StageX tools, which is essentially you have a seed of 256 bytes, or something like that, where you start compilation and essentially compile everything, compile everything from that. So, and of course, these bytes are auditable. You can read that and you can verify what it is. And then everything is reproducible. Of course, their kind of goal is to do the reproduction on multiple zones. So there is then consensus about if this is correct or not. Then, of course, if it's not, then there is auditor who can verify. If this completes, then we can go to my story, to user-controlled root of trust and chain of trust. Because in this environment, of course, I have this problem of this various tooling, of this silicon vendor tooling, stitching, signing, and various NDA tooling, which maybe I can deploy in some places, but I cannot publish. But I could divide that problem into different cubes, which are triggered by some coordination, maybe some expert also triggering those events. And thanks to that, it also, some of those cubes get to kernel level of the keys in the key structure. And at some point, I have I have released. I will not go deep into that. If someone wants to talk with me about Zarhus provisioning box or VM, that's fine. Okay, evidence of that could go to even some compliance system. And the case that investors looking for is essentially also inspired by one of the guests of the Dasharo user group, Artur Rasmussen. He's got project BSD3, mandatory access control LLM UI. And this is essentially idea of UI of inference, where you have controlled policy for who can access with what models and with what data the GPU. And of course, this release coming here to those components, and you see that there is some like a loop here and relation between stuff. Of course, we can have various security stuff here, and very likely this is our another cubes, and essentially all that have to be hosted somewhere, because otherwise it would not fit in one machine. And final thing is, at some point someone can have concerns about any of these components and may demand, okay, I want to check you. I want to know what's going on. So we can gather the trails, and various auditors could inspect that, how the system operates, and if there was anything compromised, or who's the blame, who is to blame in case of vulnerability. But that just, okay. Okay, I have so much more, but anyway. So state of Qubes Air on 2025. So of course this coming with 4.3, but let's go from down. So I'm really about this root of trust, chain of trust, provisioning, and user controlled stuff, because if you have this one, you can provision your laptop, provision your server, and use very trustworthy stack on those sites. What we're doing, so what Michał presented on the Qubes Air firmware hardware presentation is essentially this. So you know that we have one platform which is already there. So hardware is there, another is in the works. Dasharo is in the works for the AMD Gigabyte. We're planning also BMC stuff. Qubes OS for servers is discussed, and probably will be further discussion. How the qrexec will work on the server side is also something to be probably planned, or maybe even we have some ideas. Vertically integrated applications that I showed on the previous slide are not there yet. We're working on that. In case of laptops, you already have Nova Custom certified laptops, Nitro KeyGuard also certified laptops, so you can get some certified laptops. So this is like mostly done. And apps, of course, have to be imagined in this ecosystem. In case of this system for provisioning, I would like to also approach Qubes with that, but still this is rather planned than in progress. We already have hardware and Dasharo. We're planning virtual machine deployment of the system, and this is how it looks like. So this is also to point you that this coming in an R43RC, and I already tested this one. Okay, and I wanted to do the demo, but I would not have time. This would be not that easy, so I have to delegate that to Hackathon. But the demo was essentially this. I got some Bastion with SSH, and I essentially do the reverse tunnel, I guess here. So this is our Qubes R4.3 RC2. This was hard kernel Odroid H4, some small box. And this is our laptop with 4.2. And essentially the goal is to execute command here, which will do something here. In this case, we just wanted to do also two separate machines. And we want to have qrexec controlled policy here. So we did QVM copy to VM to the VM, which is here. The VM2 remote is essentially VM2 here. And we copy some text file. And essentially, qrexec policy helps us that this has to go through the relay. Leverage the SSH layer for transport. There is another relay on the other side, on the laptop side. And then there is another policy which tells this have to land here. And then we have the file. Of course, this is just a copying file example. There can be many more. We can GPG split do like that. SSH split do like that. And way more, like use my very confidential tool to do very confidential action at the other side of the ocean. Yeah, this could be done. Of course, I have very bad pictures. I tried that. This works. You have to trust me. Pictures are terrible. So there are a couple. So essentially, maybe what is going on here quickly. So this one is. So this is the policy. This is configuration of the bastion. So this is my relay. This green one. This is one of the VMs from which I'm calling the QVM copy. This is just proof in the journal CTL that really something happened here. I guess slides have way better quality of the picture because this is even distracted by. And essentially, so I'm trying to QVM copy, and this is my Odroid one side of the equation, yeah? And when I trigger it, then I have this pop-up asking me, of course, I should put it in the VM, but I decided to put it also, to put the file maybe other way. I'm just remotely getting the information, okay, someone trying to execute something, and because remote relay just mentioning what you would like to do with this incoming file. And I just put the work, and the file landed in work, and you can see that this is the file that I sent it. Like, okay, maybe you cannot see because I should show it at the beginning, but trust me, this is the file I sent it on the other side. There is documentation. So yeah, so if you want to reproduce that, there is documentation from Qubes OS team. Congratulations to Marek and the team. Frederick, I guess, was a huge contributor to that. On Matrix thread, I described a little bit my story, and there is gist that I posted with reproduction procedure. What else? Conclusion. Hardware, firmware, and software are reasonably mature for development of vertically integrated applications with Qubes Air. For hardware vendors, it is time to think how to deliver certified hardware to meet those requirements to build the applications. For firmware, of course, we have to glue that together and help building the integration. Software developers can think about the vertically integrated application. And I have another big slide, but that's last one, I promise. So essentially, my point is like this. I would like to deliver this one to make releases which will do the certified devices. Not only the laptop, the thin client, but also the server, but also the device that will do all this signing, all this procedure. And what you can do with that, yeah? So we have community, we have different person. There is this one, yeah? Can be this one in community, that's fine, completely. You have to vote with your wallet, because that way you support the ecosystem and move the ecosystem forward. I understand this is expensive, more expensive than the regular one, but if you want those applications, you want trustworthy ecosystem, then there have to be price for that. Of course, if you don't have money, you can promote, that's less money. There are small medium enterprises which could be partner for the pilot programs of introducing that. If you want, just contact me. There could be hardware OEMs and ODMs which produce the hardware, and they could just think about building with open source from day one. That would be great. Or if you are in this organization, just tell your director, manager, founder, whoever to do that. There could be value-added resellers who sell the hardware with Qubes OS certification. That's always welcome. And also there can be investors, sponsors, or grant providers who have too much this one or this one or this one and would like to fund us. So we are very welcome. You are very welcome. If you want to see some kind of future which is described on these pictures, then please contact us. That's it. Do we have time for questions?
5 minutes.
Okay, 5 minutes for questions.
On the side of the remote VM, so you're working on getting Qubes on the server. How do you envision it at a larger scale when you need to basically have VM migration and stuff like that? Is it something that you plan to move to Qubes, or?
Yeah, I think we are not tied to Qubes on Qubes Air. It's not like I understand XCPNG is also a completely valid case. Maybe this is for some smaller deployments, maybe more home lab, small, medium enterprises. XCP-ng is, of course, by the way, Marek, in the documentation clearly, I don't know if you wrote the documentation, but in the documentation it is clearly stated that it doesn't have to be Qubes on the other side. There can be anything, to be honest. Yeah, anything that has the qrexec client VM.
You don't. Well, you need the some ability to receive the connection, whatever transport you use. Example, use SSH, so you need something that you can use connect with SSH.
And the other thing is, of course, there would be great on the server side. There is also some policy, policy control. So that's I don't think if there is anything like that in XCP-ng.
No, not yet.
Yeah.
But some things to discuss.
You don't need it strictly. Yeah, for the policy, on your slide you even included that if you use Qubes on both sides, you have 2 places to evaluate policy here. So there is a local policy and the remote policy. And depending on your use case and threat model, you can limit it only to the local policy and remove the remote one if you are fine with that.
Yeah, yeah. So essentially this side, it doesn't have to be Qubes.
It doesn't have to be Qubes. Yeah. So I have a question.
Sure.
So here we set up some local and remote Qubes system, and you need to manually kind of trust that you are connecting to the correct machine. Mm-hmm. What do you think about using some remote attestation here to ensure nobody's
yeah, you're singing my song, so
yeah.
you know what I'm thinking about it. Of course, it would be great if this kind of connection will be established only based on the evidence that this site is genuine. And of course, in the application like this one, it is very important. It's extremely important because we don't want like any device to be able to trigger that. So we can imagine that if we're building Dasharo, only someone with Dasharo device, sign it with 3MDEP keys, so we are sure that this is a 3MDEP employee and so on can access certain level of keys here. So I completely agree, and of course if there will be TrenchBoot, dynamic root of trust for measurement and attestation based on PCR 17 to 22, it would be even better. Or maybe we could connect SRTM and DRTM attestation. Yeah, right. And only if we attest, then of course it's allowed to make operation. And based on that, of course, we can do based on that we can do policy. Yeah?
Yeah, I think so.
Oh.
On the later slides, yeah, that one. The qrexec policy that you are running on the server side, on the remote, yeah, that one. I guess it's a different instance of qrexec than the one that manages the host Qubes. Right?
Yes, but in the Joanna architecture, maybe even that one, you see that this could be essentially there could be admin VM which kind of deploys the same policy or adequate policy on and control that situation. Mm-hmm. So in theory, it could be like in XCP-ng, it could be like a admin VM and communicating with the client side to deploy adequate policies.
Okay, thanks.
Yeah, that would resolve like mass configuration problem. Yeah.
There is an issue on GitHub for like kind of nested qrexec policy for a case similar to this, mm-hmm. for like having a management VM controlling part of the policy to like be able to create and fully manage some of the VMs. Okay. There's a long discussion. We have some ideas and no conclusion.
Complex
yeah.
problems.
Yeah.
Okay.
Thank you.
Last one because there's.
Presentation now. So the idea with Qubes Air is or one of the ideas is to reduce, make the interfaces the thinnest possible. I'm wondering what are the thinnest interfaces that we have? Because, for example, you can do it via the network. Maybe you could also do it via USB. What would be the best one, assuming a situation where you want to have a secure device like a laptop.
I'm not
That
sure
takes
if the because that's transport layer. Like that sounds to me like transport layer, not the interface. Interface seem to be protocol of qrexec. Like this is interface, and you only understand that. Not transport layer is different. I don't know, Mark, but
what
you know.
are the transport layers being considered? I think right now it's just network.
Yeah, currently there's example just network and SSH because it's easy to set up, but yeah.
Okay.
The mechanism is very flexible.
Okay.
So you can write essentially the transport mechanism. You're writing the transport mechanism, because you're just scripting the how you would like to transfer this information. Okay, time out. Thank you very much.
Thank you.